year was 1791, a time of great upheaval in Europe. Across the English Channel, the French Revolution raged, challenging monarchs and traditions. But in the heart of London, far from the echoes of political turmoil, a boy was born into obscurity. A boy who would one day reshape the understanding of electricity and magnetism. His name was Michael Faraday. Born into a working-class family, young Michael knew little of privilege or comfort. His father, James Faraday, was a blacksmith, a man of quiet resilience who struggled to provide for his growing family. His mother, Margaret, bore the weight of their hardships with unwavering strength. Money was scarce, food was simple, and education, a luxury beyond reach. From an early age, Michael displayed a restless curiosity. But curiosity alone could not put bread on the table. Formal schooling was out of the question, so at the age of 13, he entered the world of work, a bookbinder's apprentice. For most, such a life would mean a future of menial labor. But for Faraday, it was an opportunity disguised as necessity. Every book he bound was a gateway to a new world. Science, electricity, chemistry. The words leaped from the pages of the books he handled, sparking something deep within him. He devoured them, reading late into the night by candlelight. Jane Marcet's Conversations on Chemistry became his teacher, its pages revealing the secrets of the natural world. But books could only take him so far. He longed for more. He longed to see experiments with his own eyes, to feel the spark of discovery in his hands. Fate, it seemed, had been listening. One day, a customer at the bookshop handed him a ticket to a series of public lectures at the Royal Institution, delivered by none other than Sir Humphry Davy, one of England's most celebrated chemists. This was his chance. He could scarcely believe his fortune. On the day of the lecture, he stood in the crowd, mesmerized. Davy spoke of electrochemistry, of the hidden forces within metals and gases, of discoveries that pushed the boundaries of human knowledge. Faraday sat transfixed, scribbling notes furiously, his mind alight with wonder. Then an idea took hold, one that would change his life forever. What if he could work for Davy? What if he could escape the bindery and enter the world of science? It was a foolish dream, he knew. Who would take a bookbinder's apprentice seriously? But Faraday was not one to surrender to doubt. He compiled his lecture notes into a beautifully bound book, his own handwritten testament to his passion. With trembling hands, he sent it to Davy, along with a simple request. An opportunity to serve, to learn, to contribute. Days passed, then weeks. Silence. Had he overreached? Had Davy laughed at his audacity? And then the letter arrived. Davy had read his notes, and he was impressed. But there was no position available. Disappointment struck, but Faraday did not despair. He continued his work, binding books by day and studying science by night. Then, just when hope seemed lost, fate intervened once more. Davy's assistant had been dismissed. A vacancy had opened, and Davy, remembering the eager young bookbinder, sent for him. Faraday could scarcely believe it. The moment he had dreamed of was real. He was to join the Royal Institution, but the path ahead was uncertain. He was not a gentleman of science. He was a servant, a lower-class apprentice among scholars and noblemen. Would they accept him, or would they cast him aside? A mere curiosity with no place in their world. As he walked through the doors of the Royal Institution, he took a deep breath. The air was thick with the scent of chemicals, the hum of intellectual pursuit filling the corridors. He had stepped into a world far removed from the bindery. This was his chance, and he would not waste it. The doors of the Royal Institution closed behind him, and with them his old life. No longer was he just Michael Faraday, the bookbinder's apprentice. Now he was an assistant to one of England's greatest chemists. But the road ahead was anything but smooth. At first, he was no more than a servant. He cleaned glassware, prepared chemicals, and swept the floors of the laboratory. He was expected to remain silent, to observe but not to question. The other assistants, young men of wealth and status, looked down on him. He was not one of them, but Faraday did not mind. He watched, listened, absorbed everything around him. Humphry Davy was a man of brilliance, but also of pride. He had risen through the ranks of science, a self-made man in a world of aristocratic scholars. Perhaps that was why, despite his reservations, he saw something in Faraday. Something familiar, but respect was not given freely. It had to be earned. Then, An opportunity came, one that would test Faraday's patience and resolve. In 1813, Davy was invited on a grand scientific tour of Europe. It was the chance of a lifetime. Meetings with the great minds of the continent, visits to the laboratories of Paris, Florence, Rome. Davy would study the chemical secrets of Europe's greatest institutions, exchanging ideas with the likes of Gay-Lussac and Ampere. But he needed an assistant, someone to carry his equipment, prepare his experiments, and document his findings. Faraday was chosen. Excitement surged through him. He would see the world, stand in the halls of the great universities, witness the latest discoveries with his own eyes. But reality soon proved far less romantic. The journey began with prestige, but quickly turned into hardship. Davy's wife, Jane, resented the presence of a mere assistant. She treated Faraday as a servant, not a scholar. On the road, he was expected to polish boots, pack luggage, arrange accommodations. The intellectual wonders he had dreamed of were overshadowed by humiliation. Still, he endured. In France, he stood in the presence of Napoleon's scientists, watching as Davy debated the nature of elements. In Italy, he saw the experiments of Alessandro Volta, whose work on electricity was reshaping scientific thought. In Florence, he witnessed the first use of a powerful burning lens to decompose compounds, a glimpse into the mysteries of chemical bonds. He listened, he learned, but he was always on the outside. One evening, as Davy prepared for a demonstration, an argument broke out. A crucial piece of equipment had been misplaced. Frustration flared. Then, Faraday spoke up. A quiet suggestion, a way to replicate the setup with available materials. Davy hesitated, then nodded. The experiment proceeded flawlessly. For the first time, Davy looked at Faraday not as a servant, but as a mind worth cultivating. Slowly, things changed. Faraday's duties expanded beyond menial tasks. He assisted in experiments. He took notes not as a secretary but as a scientist. He began to think, to theorize, to question. But even as he gained knowledge, the shadows of class distinction loomed over him. Upon returning to England in 1815, Faraday expected recognition. He had proven himself. But the Royal Society, the gatekeepers of British science, still saw him as an outsider. He had no university degree, no noble birth, no place among gentlemen. He was given work, but never true acknowledgement. Years passed. He continued assisting Davy, working in the background as others took credit. Yet he did not falter. He buried himself in experiments, in books, in the pursuit of knowledge. Then, fate intervened once more. Davy's health began to decline. The once great chemist, whose hands had unraveled the secrets of elements, found himself weakened. His eyesight failed. His body grew frail. The laboratory no longer belonged to him alone. Faraday, once the servant, now stood as the true mind behind the experiments. And then, the moment arrived. One day a problem emerged. A complex chemical reaction, one that had puzzled the institution's brightest minds. Davy, struggling with his own limitations, turned to his assistant. "Faraday," he said, "what do you think?" It was the first time Davy had asked for his opinion. Faraday's heart pounded. He knew the answer. He had known it for weeks. He had studied, calculated, tested in his own quiet way. And now he spoke. The experiment was conducted. The results flawless. The other scientists murmured. Who was this man? This bookbinder's apprentice who had outthought them all? The murmurs became whispers. The whispers became recognition. Faraday had done more than serve. He had contributed. And Davy knew it. But pride is a cruel thing. Though he admired Faraday's mind, though he knew his assistant had become his equal, Davy never openly acknowledged it. He remained distant, withholding the validation Faraday had long sought. Yet he could not stop what had already begun. The world of science had noticed, and Michael Faraday was only just beginning. The doors of the Royal Institution no longer felt like barriers. They felt like home. Michael Faraday had fought for his place in science, and though he was still seen as an outsider by some, his work spoke for itself. The boy who once bound books was now binding together the very forces of nature. And yet, his greatest discoveries still lay ahead. His early years at the institution were filled with chemistry, bubbling reactions, strange vapors, metals dissolving in acids, and gases behaving in ways no one quite understood. Every day brought a new experiment, a new challenge. He worked tirelessly, refining techniques, pushing the boundaries of what was known. He had no noble title, no wealth, but he had something more valuable, a mind that refused to stop questioning. Then, the first breakthrough came. In 1825, while investigating the composition of illuminating gas, used to light the streets of London, Faraday isolated a mysterious, colorless liquid. It had a peculiar odor, unlike anything he had encountered before. He studied it carefully, tested its properties, and realized he had discovered something new. Benzene, a substance that would one day become the backbone of organic chemistry, of industrial processes, of dyes, of plastics, of medicine. Yet, at that moment, it was simply another mystery unraveled, another puzzle solved. He did not seek fame for it. He did not patent it. He simply documented what he had found, and moved on. There was always another question waiting. But chemistry was not his only fascination. Another force, invisible, powerful, had begun to take hold of his mind. Electricity. The world knew of it, but only in fragments. Benjamin Franklin had tamed lightning with a kite and key. Luigi Galvani had made dead frogs twitch with electric currents. Alessandro Volta had built the first battery, proving that electricity could be stored and controlled. But still, no one understood its true nature. Was it a fluid? A vibration? A force? Faraday wanted to know. One day, while experimenting with wires and magnets, he noticed something strange. A current-carrying wire, placed near a magnetic pole, did not simply attract or repel. It moved. It spun, as if it were trying to escape, to dance in the presence of the magnet. He was seeing something new. Carefully, meticulously, he designed an experiment. A small pool of mercury, a vertical wire, partially submerged, a magnet placed nearby. He connected a battery, and then, it happened. The wire began to rotate around the magnet. It was simple, but revolutionary. For the first time in history, electricity had been converted into continuous motion. Electromagnetic rotation. He did not know it then, but this tiny experiment, this spinning wire, was the seed from which the entire modern world would grow. The electric motor, the dynamo, the turbines that power cities, the engines that drive industry. All of it began here, in a quiet laboratory, with a man who had once been dismissed as a mere assistant. Word of his discovery spread. Scientists marveled at the implications. What did this mean for the future of energy? Could motion be created from electricity on a larger scale? Could this be the key to machines that moved without steam, without fire, without fuel? Faraday did not celebrate. He did not pause to bask in recognition. There was still too much left unanswered. If electricity could create motion, could motion create electricity? Could the process work in reverse? He would not rest until he found out. But there were obstacles. Critics, skeptics, and men who dismissed him, who whispered that his discoveries were nothing more than curiosities, that he lacked the formal training to be a true physicist. The Royal Society still hesitated to fully embrace him. Class barriers had not vanished. And then, there was Davy. His old mentor, once his greatest supporter, now seemed to resent his rising success. Davy had been the master. Faraday had been the apprentice. That was the natural order, wasn't it? But now the apprentice was making discoveries that outshone those of the master. The tension was unspoken, but palpable. Davy, still president of the Royal Society, subtly blocked Faraday's nominations, ensured that others received credit first, made it clear that though Faraday had talent, he had not yet earned the right to stand among the elite. It should have broken him. It did not. Instead, Faraday threw himself deeper into his work. He studied electrolysis, defining the fundamental laws of how electric currents split molecules apart. He named terms that would become the foundation of modern chemistry: electrode, ion, cathode, anode. He explored the nature of electric fields, sensing long before anyone else that electricity was not a mere fluid or charge, but something far stranger. And through it all, he remained humble. He did not seek wealth. He did not demand recognition. He simply experimented. And slowly, steadily, the world began to realize that Michael Faraday was not just another scientist. He was something far rarer. A man who saw the hidden forces of the universe not as puzzles to be conquered, but as wonders to be understood. And he was only getting started. The laboratory was silent, save for the soft crackle of a burning candle and the faint hum of distant city life. The air smelled of metal, ink, and aged parchment. In the dim glow, Michael Faraday stood over his workbench, eyes locked on a simple coil of wire, a loop of copper, wound with careful precision. In his hands, a magnet. Nothing extraordinary. Nothing the world had not seen before. And yet, something was missing. The question had haunted him for months. Years, perhaps. If electricity could create motion, as he had proven with his spinning wire and the force of electromagnetism, could motion, in turn, create electricity? The very idea felt absurd. Impossible, even. Yet, something deep within him whispered otherwise. He had learned to trust that whisper. He took a breath. Steady. Deliberate. He moved the magnet through the coil. Nothing. He frowned. Tried again. Nothing. His hands tightened around the iron bar, frustration threatening to take hold. He had come too far for this to be an illusion. The laws of nature did not tease. They revealed themselves, but only to those who persisted. He moved slower this time, more carefully. The magnet passed through the coil, and then, a flicker. His heart pounded. His fingers trembled. He repeated the motion. Again, a flicker. A faint, fleeting pulse of current, barely perceptible, yet unmistakable. It vanished the moment the magnet stopped moving. His breath caught in his throat. This was it. Electricity, born from motion. He ran the experiment again and again, each time refining, improving, eliminating doubt. He added a second coil, placed beside the first, connected only by air. He pulsed a current through the first coil, and in the second, another flicker. A current had appeared, as if by magic. But it was no magic. It was a force that had been waiting for the right hands to reveal it. Electromagnetic induction. He stepped back, fingers resting lightly on the edge of the workbench. His mind raced. This was more than a simple effect. This was a doorway. Power unseen, yet omnipresent. A force that did not rely on fire or steam, on burning coal or boiling water. A force that, if harnessed, could change everything. The implications were staggering. What if, instead of massive steam engines and gears, entire industries could be powered by a simple coil and a spinning magnet? What if electricity, this elusive, untamed phenomenon, could be summoned not from chemical reactions or rare materials, but from the very motion of the world itself? Could dynamos be built? Could energy be made endless? His pulse quickened. There was no one in the room to share this moment. No crowd of scholars. No nobleman watching with skepticism. No audience waiting for a conclusion. There was only Faraday and the quiet realization that he had just unlocked one of nature's deepest secrets. But he could not keep it to himself. He documented everything. Pages filled with notes, equations, observations. He repeated the experiment tirelessly, ensuring there was no mistake. And when he was certain, when there was no doubt left, he prepared to reveal it to the world. Yet the world was not ready. His peers listened. Some nodded in quiet admiration. Others dismissed it. A curiosity, they called it. An interesting phenomenon. But practical? Useful? No. What purpose could it possibly serve? Faraday did not argue. He had learned long ago that true discoveries did not need to be shouted. Time would prove him right. But one man understood. A young physicist named James Clerk Maxwell. He saw beyond the skepticism. He saw what Faraday saw. Though Maxwell's mathematical mind worked differently, more rigid, more structured. He recognized the truth in Faraday's invisible lines of force, in his insistence that electricity and magnetism were not separate forces, but one. Still, recognition was slow. In the following years, Faraday refined his work, exploring deeper, pushing further. He demonstrated that electric fields and magnetic fields were not isolated phenomena but part of a single, unified reality. He continued his lectures, his experiments, his quiet, relentless pursuit of knowledge. But even as his discoveries grew, so too did something else. The shadows. Fatigue crept in. The years of tireless work began to wear him down. His hands, once steady as steel, trembled ever so slightly. His memory, once a fortress of knowledge, betrayed him in moments of forgetfulness. And yet, he continued. He had done what he set out to do. The spark had been ignited. The flame of understanding would only grow. He no longer needed to prove himself. Not to Davy, who had passed. Not to the Royal Society who could no longer ignore his genius. Not to those who once doubted, who once scoffed. Because now, the world was beginning to listen. The age of electricity was coming. And it had begun with a magnet, a coil of wire, and the mind of Michael Faraday. The magnet spun. The coil remained still. And yet, something unseen moved between them. An invisible force called into existence by motion alone. The world had known about electricity for centuries. Static sparks, lightning, the slow corrosion of metals in chemical cells, but never like this. Never as something that could be generated, sustained, controlled. Michael Faraday stood over his apparatus, adjusting the wires, ensuring the connections were firm. He had spent years refining this principle, years proving what he had once only suspected. A simple hand-crank device, no batteries, no chemicals. Yet when it turned, when motion fed its coils, current flowed. This was no ordinary experiment. This was the birth of the dynamo, a machine that could convert movement into electricity, endlessly without depletion. It was not just a discovery. It was a revolution waiting to unfold. And yet, so few saw what he saw. The world around him was still bound by the age of steam. Factories roared with the grinding of coal-fed engines. Railways stretched like iron veins across continents, powered by fire and water. Everything was built on combustion, on expansion, on the brute force of pressure and gears. Who would replace it with something invisible? Who would abandon the certainty of steam for the ghostly pull of electromagnetism? His colleagues studied the dynamo with cautious interest. A clever effect, they said. But a machine of the future? No. Faraday was undeterred. He knew that great changes did not come overnight. He had spent years proving electromagnetic induction was real, and he would spend years more if he had to. The experiments continued. He built larger models, refining the coils, testing different materials. Copper wound tighter, iron cores shaped differently, magnets arranged at precise angles. Each iteration was an improvement, an evolution, and slowly the efficiency increased. More power, smoother currents. And then, a moment of clarity. If a magnet could generate electricity by moving past a coil, what if coils moved past each other? The idea consumed him. He envisioned machines, great rotating devices with no need for fire, no need for fuel beyond their own motion. He imagined a future where energy could flow freely, drawn from the very motion of the world itself. But the world was not ready. Industry had no use for an invention that did not yet power anything. The Royal Society took note, but its members did not grasp the full implications. Even those who admired Faraday struggled to see beyond the steam-driven present. Still, he persisted. Then, without warning, a new challenge emerged. His body, once tireless, began to fail him. The experiments had not exhausted him, but time had. He found himself growing weaker, his hands less steady, his memory slipping. The mind that had unraveled the secrets of electromagnetic fields now struggled with the simplest recollections. First, he ignored it. He worked through the exhaustion, through the moments of forgetfulness. He had spent his life unraveling nature's mysteries. Surely, he could solve this one too. But no force of will could fight the inevitable. The experiments became harder, the calculations more difficult. He knew what was coming. One evening, as he stood before his workbench, he traced the curves of his coils with his fingertips, feeling the cool, smooth surface of the copper windings. The dynamo was real. It worked. But would it be remembered? Would the world understand what it had been given? He was no businessman. He did not seek wealth or patents. He had never pursued recognition, only understanding. He had given the world a machine, but it was up to others to use it. And so he made peace with it. The world would change whether it realized it now or not. The age of steam was ending. The age of electricity was coming. And it had begun with a spinning magnet, a coil of copper, and the quiet persistence of Michael Faraday. The room was silent, save for the occasional crackle of electricity. The air smelled of ozone, sharp and metallic. In the dim glow of candlelight, Michael Faraday stood before his next experiment. A copper box suspended in the air, wires trailing from its edges. It was simple, deceptively so. Just a hollow enclosure, a shield of metal. And yet, within it lay the answer to a question that had troubled him for years. What was electricity? Men had studied it, tamed it, harnessed it in crude ways, but no one truly understood it. Was it a fluid, as Franklin had believed? A vibration? A pressure of charged particles? The theories shifted, but the answers remained elusive. Faraday had spent decades unraveling the hidden forces of nature, and now, once again, he found himself staring into the unknown. He moved slowly, adjusting the connections, ensuring every wire was in place. Outside the box, he arranged metal rods, prepared to flood the enclosure with electric charge. If electricity behaved the way many believed, the interior should light up, become alive with energy. The force should seep through the walls, penetrate, spread. But something told him otherwise. He flipped the switch. A spark leaped, dancing across the surface of the copper. The outer shell glowed, humming with invisible energy. The air around it tingled. And yet, inside the box, nothing. Faraday's pulse quickened. He reached inside, slowly, hesitantly, half expecting the sting of a shock. But there was none. The inside remained untouched, silent, unaffected. The charge had gathered on the exterior, but had not passed through. Electricity, it seemed, did not flow like a fluid after all. It was something different, something stranger. He tested again and again. Larger enclosures, different metals, stronger charges. The result was always the same. The field remained on the outside. The inside was safe. It was a discovery both profound and practical. Electric fields could be blocked, contained, shielded. If an electrical storm raged outside, a properly enclosed space would remain untouched. If delicate instruments needed protection, they could be placed within a metallic shell. If radio waves, if signals, if currents flowed through space, they could be controlled, guided, isolated. The implications stretched far beyond his own time. The Faraday Cage. It was a simple concept. And yet it would one day shield entire cities, protect astronauts in space, safeguard aircraft from lightning, preserve delicate electronics from interference. A century later, his principle would be at the heart of every secure communication, every laboratory, every machine designed to handle the raw forces of nature without being consumed by them. But in that moment, standing in his dimly lit laboratory, Faraday was not thinking of the future. He was thinking of the nature of electricity itself. The Royal Society had always viewed him with skepticism. He had no formal education. He spoke in simple terms, without the rigid equations of the mathematicians. And yet, time and again, his hands uncovered truths they could not deny. But still, they doubted. He had proposed something radical, an idea that would shake the very foundation of physics. That electricity, magnetism, and even light itself were not isolated forces, but aspects of the same fundamental phenomenon. The idea was too strange, too unproven. The world was not ready to listen. Not yet, but he could feel it. He could see it. The way electric currents curved, the way magnetic fields stretched invisibly through space, the way lines of force seemed to shape the universe itself. He had no equations to prove it, no formal model, just an instinct, a vision. And that was not enough. The critics whispered. He was brilliant, yes, but he lacked the precision of the great mathematicians. He saw too much, yet explained too little. He did not argue. He did not defend himself. He simply continued. For every discovery they dismissed, another came to take its place. He refined electrolysis, naming the fundamental concepts of ions, anodes, cathodes, words that would define chemistry for centuries to come. He demonstrated how magnetic fields could store energy, paving the way for future generations to build upon his work. And slowly, the world began to take notice. He was no longer the bookbinder's apprentice, no longer merely Davy's assistant. He was Faraday. And even as his hands grew unsteady, as his memory began to fail him, as the weight of years pressed upon him, he knew that the work was not yet done. There was still so much left to understand, still so many secrets waiting to be revealed, and still he worked. The lines of force stretched invisibly across space, their shapes forming patterns that only one man could see. Michael Faraday traced their imagined curves in the air, his fingers moving as though guiding something unseen. To others, it was madness. An old man's obsession with things that could not be measured, things that could not be calculated. The mathematicians scoffed. To them, science belonged to numbers, to formulas, to precise calculations etched onto paper. The world could be described, predicted, controlled, if only one knew the right equations. And Faraday? He had no equations. He spoke of forces that curved and stretched like living things. He described electricity not as isolated sparks, but as a field, an ocean of influence spreading outward, unseen but real. But where was the proof? Where were the numbers? The Royal Society tolerated him, admired him even, but they did not fully trust him. The great men of physics, Laplace, Poisson, Ampere, built their reputations on logic, on strict mathematical reasoning. Faraday's ideas, they felt more like intuition, more like imagination. Yet time and again he was right. His experiments spoke where his words could not. Electromagnetic rotation, induction, electrolysis, the Faraday cage. Every discovery had been met with doubt, and every time nature itself had proven him correct. But this was different. He was no longer just presenting new effects, new machines. He was asking them to rethink the very fabric of reality. Electricity and magnetism were not separate forces, he insisted. They were one and the same, bound together by laws that no one yet understood. He could feel it, see it in the way currents flowed, in the way fields stretched. But he had no mathematical proof. The physicists shook their heads. It was a bold claim, but nothing more. And yet, afar away, across the countryside, a young man listened. James Clerk Maxwell. He was everything Faraday was not, formally educated, steeped in mathematics, fluent in the language of equations. But he saw something in Faraday's vision. He studied his experiments, read his papers, traced the invisible forces with his own mind. And then, with the precision of a trained mathematician, he did what Faraday could not. He translated the vision into numbers. The equations came slowly at first, hesitant, searching. Then, one by one, they formed something breathtaking. A set of rules that defined how electric and magnetic fields interacted, how they moved through space, how they were, in truth, two faces of the same force. The mathematics were beautiful, elegant, unshakable, and in that moment the world changed. Faraday had always known. But now, finally, he was understood. Electricity and magnetism were not separate forces. They were part of a single, unified reality, electromagnetism. It was a triumph, but not one that Faraday would ever fully witness. His health was failing. The years of relentless experimentation had taken their toll. His hands, once so steady, now trembled. His memory, once a fortress of knowledge, had begun to fade. He had given everything to science, and now science would move on without him. But even as his body weakened, his spirit remained strong. He continued his lectures, his experiments, his search for truth. He no longer cared for recognition, he never had. The work was its own reward. Yet, despite everything, the doubt had never fully disappeared. There were still those who dismissed him, who whispered that his greatest discoveries were accidents, that he lacked the intellectual rigor of a true physicist. He did not argue. He simply continued. And as he sat in his quiet study, gazing at the coils and magnets that had once whispered their secrets to him, he smiled. The battle was over. The world had changed. And the future belonged to the invisible forces he had spent a lifetime revealing. The streets of London hummed with life, horse-drawn carriages rattling over cobblestone roads, the scent of coal smoke heavy in the air. Factories churned, steam billowed, and gas lamps flickered in the evening gloom. The city was alive, but it was changing. Electricity was no longer a curiosity. It was creeping into industry, into homes, into the fabric of everyday life. And at the heart of it all, Michael Faraday. His name was spoken with reverence now. No longer just the bookbinder's apprentice, no longer merely Davy's assistant. He was Faraday, the man who had unraveled the invisible forces that powered the world. He had never sought fame. It did not interest him. Wealth, recognition, prestige, these were things others chased. He had only ever wanted to understand, to experiment, to reveal the mysteries of nature. And yet, fame had come for him anyway. The Royal Institution, once a place where he had scrubbed floors and cleaned glassware, was now his domain. People gathered in great halls to hear him speak, to watch as he brought science to life. He was not like the other lecturers, cold, distant, speaking only in complex formulas. No, Faraday spoke with passion. He made science alive. His Christmas lectures became legendary. The young and the old alike sat transfixed as he demonstrated the wonders of electricity, magnetism, chemistry. He showed them how light could be bent, how forces unseen shaped the world around them. He believed knowledge should not be locked away in books or reserved for the privileged few. It should be shared freely, openly. And so he gave it away. He refused to patent his discoveries. The dynamo, electromagnetic induction, the Faraday cage. Ideas that could have made him wealthy beyond imagination, he gave them to the world. Others could profit. Others could build industries, empires. He cared only for the science. But time does not wait. His hands trembled more now. His mind, once a steel trap, sometimes faltered. The memories did not come as easily. The calculations, once so fluid, so natural, took longer to form. And yet, he pressed on. Because something extraordinary was happening. Faraday had always struggled to explain his greatest ideas in the language of mathematics. He saw the world in lines of force, in fields stretching invisibly through space. But when he tried to express these visions in numbers, the language failed him. But another had taken up the challenge. James Clerk Maxwell. The young Scottish physicist had spent years studying Faraday's work, absorbing every experiment, every insight. Where Faraday had seen patterns, Maxwell found equations. He took the invisible lines of force and wove them into a framework of mathematics so powerful, so precise, that it would reshape physics forever. Maxwell's equations. For simple, elegant formulas that described the very nature of electricity and magnetism. They were not separate forces. They were one. Faraday had always known it. But now the world had proof. The implications were staggering. The equations predicted something no one had expected. If an electric field could create a magnetic field, and a magnetic field could create an electric field, then what if they did so in a continuous self-sustaining cycle? What if they moved together? Light. Maxwell's equations suggested that light itself was an electromagnetic wave, an oscillating field traveling through space at an unimaginable speed. It was not just a force, it was the force that illuminated the universe. The discovery was monumental. Faraday knew what it meant. He knew his intuition had been right all along. But he also knew he was running out of time. He was still revered, still respected, but his strength was fading. There were days when he could barely recall his own work, moments when he looked at his notes and struggled to remember how they had come to be. The once sharp mind that had peered into the heart of nature was slipping away. He withdrew from public life. The lectures became fewer, the experiments slower. He had given the world so much, and now the world moved on without him. But it did not forget. Honors came. Medals, titles, positions of prestige. The Royal Society, which had once viewed him with skepticism, now sought to place him at its head. They offered him the presidency. He declined. Power did not interest him. Recognition was meaningless. He had never worked for titles. He had worked for discovery. He chose a quiet life instead. His wife, Sarah, remained by his side, his greatest comfort. He found peace in simple things. His garden, his books, the gentle rhythm of existence. But even as his own mind faded, the world was beginning to grasp the magnitude of his contributions. Industry was waking up. Inventors were taking his ideas and turning them into machines. The dynamo, once a mere curiosity in his laboratory, was being refined, improved, prepared for mass use. The future belonged to electricity, and it had begun with him. He did not need to see it. He knew, and that was enough. The laboratory had once been his kingdom, a place of endless wonder, where invisible forces could be tamed, where questions found their answers through wire, magnet, and motion. But now it felt distant, unfamiliar. Michael Faraday stood by his workbench, staring at the coils and instruments laid before him. He had built these devices. He had drawn these circuits, conducted these experiments 100 times before. But something was wrong. The numbers did not flow as they once had. The connections, once so obvious, now seemed tangled in his mind. He reached for his notes, flipping through pages of careful handwriting, searching for the clarity that had always come so easily. Nothing. The realization came slowly, creeping, unwelcome. His mind, his greatest tool, was failing him. The signs had been there for years. The occasional lapse in memory. The growing exhaustion after long lectures. The way simple calculations, once second nature, took longer to form. At first, he had ignored it. Science had always required perseverance. He had worked through hardship before. Why should this be any different? But this was different. He knew it now. Sarah saw it too. She never spoke of it, never voiced her fears. But in the way she watched him, in the way she quietly stepped in when he forgot something, he knew. She had been his greatest companion, his anchor through years of discovery. And now, as his strength waned, she remained by his side. The royal institution still welcomed him, still sought his wisdom, but he withdrew more and more. The letters from colleagues piled up, unanswered. Invitations to speak went politely declined. He no longer trusted himself to explain the things he had once illuminated so effortlessly. And so he retreated. His home in Hampton Court, a gift from Queen Victoria herself, became his refuge. The city of London, with its factories and steam, its noise and urgency, felt distant. He preferred the quiet now, the gentle rhythm of nature, the garden where he could lose himself in simple things. He had spent a lifetime unraveling the mysteries of the universe. Now, he found solace in the mysteries of the everyday. But even as he withdrew, the world was changing. Electricity, once a mere curiosity, was finding its place in industry. Engineers were refining his dynamo, making it more efficient, more powerful. The principles he had uncovered, electromagnetic induction, electric fields, the very nature of light itself, were no longer just ideas. They were becoming reality. He saw glimpses of it. Young men eager to carry his work forward. James Clerk Maxwell's equations spreading through the scientific world, proving what he had always known. The age of steam was beginning to wane, and something new was rising. But he was fading. He could feel it in his hands, in the growing weakness that made even the simplest tasks difficult. He could feel it in his mind, the way thoughts slipped away like smoke before he could grasp them. And yet, there was no bitterness. He had lived his life for discovery, not recognition. He had never sought wealth, never patented his ideas. He had given everything to science. And now science was giving back, moving forward, growing beyond him. That was enough. One evening, as he sat in his study, he looked around at the books lining the shelves, the notes stacked neatly on his desk, pages filled with ideas, with calculations, with the silent echoes of a mind that had once burned so brightly. He traced his fingers over the worn cover of a notebook, feeling the weight of the years in his hands. He had done what he had set out to do. He had uncovered truths hidden for centuries. He had left behind something greater than himself. And as the candlelight flickered, casting long shadows against the walls, he closed his eyes. He had no more experiments to run, no more questions to answer, no more battles to fight. He had done enough, and soon, it would be time to rest. The world moved forward, but Michael Faraday moved slower. There had been a time when he walked the halls of the Royal Institution with purpose, where his hands, steady and sure, commanded the invisible forces of nature with the precision of a master craftsman. Now those halls felt distant. The workbench where he had once shaped the future sat untouched. The books, the notebooks, the instruments, all waiting for hands that no longer had the strength to use them. Hampton Court had become his world. The city of London, with its clamor and urgency, had faded into the background, replaced by the quiet rhythm of the gardens, the slow movement of the river, the distant tolling of church bells. He preferred it this way. For the first time in his life, he had nothing left to prove. The honors had come, though he had never sought them. His name, once an afterthought among the learned men of England, was now spoken with admiration, with reverence. He had been offered a knighthood, he declined. The world of titles and prestige had never interested him. He had been offered the presidency of the Royal Society. He declined that too. Leadership, politics, the weight of influence, it was not for him. He had spent his life in pursuit of knowledge, not status. And yet, there was satisfaction in knowing that the world had finally seen what he had always known to be true. Electricity was no longer a parlor trick, a scientific curiosity to amuse the wealthy. It was becoming something greater. The dynamo, once an experiment in his quiet laboratory, was being transformed into something useful. Machines that generated power, machines that carried energy from one place to another. Industry was beginning to grasp the potential of what he had uncovered. The young men who came to visit him now did not ask if his work was important. They knew. James Clerk Maxwell had done what Faraday himself never could, translated his ideas into the language of mathematics. The equations that described the lines of force, the patterns that had lived only in his mind, now existed in numbers, in symbols that the world could not ignore. Electricity and magnetism were one. Light itself was part of the same force. Faraday had always known it. Now the world knew it too. But he was not part of that world anymore. His mind, once so sharp, had begun to slip away. The forgetfulness, the confusion, it had grown worse. Some days, he struggled to recall the names of the very men who had studied under him. The knowledge was still there, buried deep, but he could no longer reach it as easily as before. He accepted it with quiet dignity. Sarah was his constant companion, her presence a comfort as the days grew slower, as the years stretched into one another. She had always understood him, always supported him, even when others doubted, even when the world dismissed him. Now, she was there when he faltered, when he forgot, when he struggled to hold on to the thoughts that had once come so effortlessly. The royal institution still wrote to him, still sought his counsel, but he rarely responded. He no longer had the strength for debates, for lectures, for the endless pursuit of discovery. The work belonged to others now, and he was at peace with that. He spent his days in the garden, watching the seasons change. He marveled at the way light played upon the leaves, at the way the wind bent the branches but never broke them. He had spent his life uncovering the laws of nature, but here, in these simple moments, he found a different kind of wonder. One evening, as he sat by the window, he watched a storm roll across the horizon. Lightning flashed, illuminating the darkened sky, the raw power of nature revealed in an instant. He had spent decades studying electricity, understanding its nature, taming it, but still, in moments like these, it felt as mysterious as ever. Perhaps that was the way it was meant to be. Science had given him answers, had allowed him to see deeper into the fabric of reality than most men ever could. But there were always more questions, always more mysteries waiting to be unraveled. And he knew, even when he was gone, the work would continue. He had laid the foundation. Others would build upon it. He had done his part, and as the storm passed, the thunder fading into the distance, he closed his eyes and let the world move on without him. The name Michael Faraday still echoed through the halls of science, even as the man himself faded from the world. His hands no longer turned the coils of wire. His mind no longer danced with the currents of electricity. But his legacy was alive. It was growing, evolving, reaching places even he had not foreseen. And in Scotland, a young physicist was about to complete what Faraday had begun. James Clerk Maxwell had spent years studying Faraday's experiments, absorbing every word, every discovery. He had never met the man. Faraday's health had declined too much by the time Maxwell came into his own, but he felt his presence in every line of force, every magnetic field, every invisible ripple that shaped the world. Faraday had seen the universe differently. While others thought in straight lines, in rigid mechanics, he had thought in fields, flowing, curving, shaping space itself. But he had never been able to describe them in the language of mathematics. Maxwell could, and so he did. The equations came slowly, forming piece by piece, shaping themselves around Faraday's great insights. He worked tirelessly, poring over notes, refining each term, searching for the perfect representation of what Faraday had always known but could never prove. And then, they were complete. For equations, elegant, precise, they described everything. How electric fields were created, how magnetic fields stretched through space, how the two were not separate, but bound together, one giving rise to the other in an endless, self-sustaining cycle. And then, something astonishing. Maxwell had not set out to explain light. He had been searching for the fundamental laws of electromagnetism, nothing more. But as he worked through the equations, as he solved for the speed at which these electromagnetic waves should travel through space, the answer appeared. A number, a speed, the speed of light. Faraday had spent his life peering into the unseen, convinced that electricity, magnetism, and light were connected. Now Maxwell had proven it. Light was not just brightness, not just an ethereal wave traveling through space. It was an electromagnetic phenomenon, a ripple of electricity and magnetism, oscillating together, racing through the universe. The implications were staggering. It meant that light and electricity were part of the same force. It meant that every flickering candle, every beam of sunlight, every star shining in the night sky, was governed by the same laws that controlled a simple magnet and coil of wire. Maxwell's work shook the foundations of physics. Scientists scrambled to test, to verify, to understand what it all meant. But there was no denying the truth. Faraday had been right. His fields were real. His vision of invisible lines of force was not an abstraction, not a trick of the mind. It was the very structure of the universe itself. But Faraday did not live to see it. His health had declined too much, his mind slipping further into fog. By the time Maxwell's equations were published, he could no longer engage with the work that bore his fingerprints. He had spent a lifetime searching, discovering, uncovering, and now, when his greatest insight had finally been validated, he was too far gone to grasp it. But perhaps he did not need to. Perhaps, in some quiet way, he had always known. He had never needed proof, never needed equations to see the truth. He had felt it in his bones, in the way electricity curved around magnets, in the way light bent through a prism. Others needed numbers to believe, but he had believed from the start. And so, even as his mind faded, even as the world moved on, the work continued. Maxwell's equations did more than explain electricity and magnetism. They opened doors no one had even imagined. They set the stage for the next great revolution. Radio waves, X-rays, microwaves, the wireless transmission of energy. The future was being written, and every line traced back to Faraday. His discoveries were no longer just experiments in a quiet laboratory. They were becoming the foundation of a new world. A world where energy could be harnessed, transmitted, controlled. A world where machines would no longer rely on steam, but on forces unseen. The industrialists were beginning to take notice. The scientists were no longer skeptical. The age of electricity was coming, and it had been born in the hands of a humble bookbinder's apprentice, who had once stood in a dusty workshop, watching a coil of wire and a moving magnet, and dared to ask the question, what if? The city no longer slept. Once, the streets of London had been lit by flickering gas lamps, their glow barely cutting through the fog. Shadows stretched between alleyways, and the night belonged to darkness. But now something had changed. Electricity had arrived. Streetlights, bright and steady, burned through the gloom, powered not by flame, but by invisible currents. Wires stretched across rooftops, carrying energy from distant generators. The hum of machines filled the air, no longer driven by steam alone, but by something quieter, more powerful. Faraday had never lived to see it. He had left the world before his ideas had truly taken hold. But his fingerprints were everywhere. The dynamo, once a curiosity in his laboratory, had become the beating heart of industry. The generators now powering cities, the motors driving factories, the systems lighting homes, each one traced back to that single moment in his workshop, when he had moved a magnet through a coil and watched, transfixed as current was born. It had taken time. At first, industry had resisted. Steam was king, the engine of progress, the power behind the machines that drove the modern age. Electricity, it was unpredictable, could not be bottled, stored, burned like coal. But men like Thomas Edison, Nikola Tesla, George Westinghouse, they had seen what others had not. They had seen what Faraday had always known. Electricity was not just another power source. It was the power source. Edison built his first power station in New York, lighting up entire neighborhoods with electric lamps. Tesla and Westinghouse took it further, proving that alternating current, based on the principles Faraday had uncovered, could carry energy across vast distances. The world was changing, and it all traced back to a single discovery, hidden in the quiet of a 19th century laboratory, where a man had spun a coil of wire and glimpsed the future. But it was not just industry. Electricity was rewriting everything. Communication. Once, messages had traveled by courier, by ship, by telegraph wires that stretched across continents. Now, thanks to the principles of electromagnetism, voices could travel through space. The telephone, the radio, the wireless transmission of signals, each one born from the same fundamental forces Faraday had spent his life exploring. Medicine. Hospitals that had once relied on candlelight now used electric lamps, allowing doctors to work through the night. X-rays, discovered through the same electromagnetic principles Faraday had uncovered, allowed physicians to see inside the human body for the first time. Transportation. The first electric trains, the first cars powered by batteries, the first experiments in wireless energy transmission. Each step forward built upon Faraday's foundation. It was unstoppable. And yet, most people did not know his name. They spoke of Edison, of Tesla, of Marconi. They marveled at the inventions, the machines, the marvels of the electrical age. But few understood that all of it, every wire, every current, every revolution of a turbine, was rooted in a discovery made decades earlier. Faraday had never sought recognition, but he had reshaped the world. His discoveries had not remained locked in dusty notebooks, buried in forgotten journals. They had been taken, transformed, built upon. The quiet experiments of a humble scientist had given birth to an age where light no longer faded with the setting sun, where machines no longer needed fire to breathe, where the very fabric of human life had been rewoven with invisible currents. And still, the revolution was only just beginning. Electricity had conquered the cities. But what lay beyond? Could it travel wirelessly? Could it power the entire planet? Could it reach the stars? Faraday had once stood in a darkened laboratory, watching a wire spin in the presence of a magnet, knowing, deep down, that he had discovered something that would change the world. And now, that world belonged to electricity. His world. The night sky had always been a mystery, vast, endless, untouchable. For centuries, men had gazed upward, wondering, dreaming, reaching. The stars burned bright, their light crossing unimaginable distances, but the space between them had always remained unknowable. Until now, the same force that once turned a simple wire in a quiet laboratory now powered the rockets that would break free from Earth's grasp. Faraday had never seen it. He had never imagined it. How could he? The world he had known had been lit by candles, moved by steam, bound by the limits of the Earth itself. But the forces he had uncovered, they had no such limits. The first radio transmissions, crackling through the air, carried voices across oceans, guided ships through fog, sent signals soaring beyond the reach of wires. The discovery of electromagnetic waves, born from Faraday's lines of force, refined by Maxwell's equations, had unleashed a revolution that stretched beyond mere machines. Communication, no longer bound to cables, no longer limited by distance. And then, something greater. In the 20th century, as scientists prepared to send objects beyond Earth's atmosphere, they faced a problem. Space was dangerous. Not just the vacuum, the cold, the radiation, but something less obvious yet just as deadly. Electrical interference. A spacecraft traveling through the unknown could be crippled by its own signals. It could be fried by a solar storm, disabled by the invisible forces moving through the cosmos. And so, Faraday's greatest invention, his simplest discovery, became its shield. The Faraday Cage, once a quiet experiment in an English laboratory, was now protecting astronauts as they soared beyond Earth. Every capsule, every module, every command center built for spaceflight used his principles. Enclosures designed to block unwanted electric fields, shielding delicate systems from the chaos of electromagnetic interference. Apollo, Gemini, Voyager. Each mission carried a piece of Faraday's legacy. And then, something even he would not have believed. Electricity. Not just as a tool, not just as a power source, but as a means of exploration. Solar panels, harvesting the energy of the sun, built on the very principles he had discovered in the flickering candlelight of the Royal Institution. Electromagnetic propulsion, using charged particles to drive spacecraft through the void, powered by the forces he had studied nearly 2 centuries before. Telescopes, no longer mere lenses, but massive radio dishes, capturing electromagnetic waves from the depths of space, decoding messages from the universe itself. He had once asked, could motion create electricity? Now, thousands of miles above Earth, satellites moved through the heavens, generating power through induction, through the very laws he had uncovered. Faraday had never known his own impact. He had never seen the electric lights of a city at night, stretching to the horizon. Never watched a radio tower send signals across continents. Never witnessed the launch of a spacecraft, engines roaring, powered by forces he had tamed. But it was all his work. It had all started with a bookbinder's apprentice, staring at a coil of wire, wondering, what if? And still, the work was not done. The future was still being written. His discoveries had sent men to the moon. What would they send next? Electricity had conquered the Earth. Now it was reaching for the stars. The world had moved far beyond the one Michael Faraday had known. Cities no longer slept, their streets bathed in electric light. Machines hummed ceaselessly, powered not by fire and steam, but by invisible currents flowing through wires, through circuits, through the very fabric of modern life. His work was everywhere. Yet so few knew his name. A smartphone, resting in the palm of a hand, transmitting messages across the globe in an instant. A train, gliding silently over tracks, driven by electric motors spinning with forces he had uncovered. A hospital, filled with machines that could see inside the human body, powered by the same electromagnetic waves he had studied. He had never seen these things, and yet they had all begun with him. The world of today, instant communication, limitless energy, boundless exploration, owed itself to a quiet man in a laboratory, moving a magnet through a coil of wire, watching as the invisible became real. But even now, even as technology surged forward, the questions had not stopped. Could electricity be harvested from the earth itself? Could energy be sent wirelessly across continents, eliminating the need for power lines, for grids, for infrastructure? Could the very fabric of space be bent, manipulated, shaped by the forces he had once struggled to understand? Scientists still searched for answers. His ideas, his discoveries, had not been buried beneath the weight of time. They had grown, evolved, multiplied. Quantum mechanics, the manipulation of individual particles, moving in ways even Faraday could not have imagined. Magnetic fields, no longer just a curiosity, but the key to fusion energy, to the very process that powers the sun. And beyond, a probe, floating through the darkness, far from Earth, its instruments silent, its systems sleeping. Then a pulse. A charge moves. A circuit completes. Power flows. Faraday's principles, guiding machines beyond the solar system. His work had not ended with his life. It had not stopped when his hands grew weak, when his mind faded, when the candlelight in his laboratory finally dimmed. It had continued, because the world had changed, and it had changed because of him. His questions had shaped the future, and the future was still being written.